In this video, I'll show you how I performed the lever segmentation using AI and how I have created. For this video, I just Google this one, Monai lever, and here you can find these videos. So in these two, Bikeaid and the freecodecamp.org, both are the same videos. You can follow any one of these. So here you can see uh, it's this length of this video is around 5 hours, so no need to see all of this. So you can as you can see, the first is the introduction, then what is unit, you can see that. Then the software installation, it is not required because we are going to use Google Colab. Then this is important, the finding the data set. So here they mentioned for the data set they have used the Kaggle and the Decathlon data set. Then preparing data is not needed at all for us because we are already having that nifty file format. Then installing the package, so here I'll just go through over the collab, and yeah, just let's go to that data set. So for the data set, go to the medicaldecathlon.com. Here we can get them research paper data and participate on some ongoing events. So for first of all, I want data. So go click on the get data. Here you can see some open source data are available. So which are the brain tumor, heart, liver, then hippocampus, then prostate copy, and that prostate tara, many things. As you can see, if in liver, the size of this liver is very huge. Details, if you go to detail, okay, it is not available, but it is going to be like a more than 30 GB of data. I don't suggest to download over Google Drive because you know what happens, sometimes it's stuck, and again if you want to restart, it is restarting from the start. Okay, so it's starting from the zero, so it is not recommended to download using Google Drive. If you're having good connection, you can try, but I strongly suggest you just go to Kaggle and just search on the lever. Okay, so in the lever, go to dataset section. Here you can find this one, liver tumor segmentation by the Lexer. So just click on that. Here you can find this data set. So this size is around 30 GB. So this is the first part of data set. So download this. It is having a 130 of CT scan segmentation liver as what it is, tumor. Okay. The second, you can get it from, go to data set, and here I'll just search liver segmentation part 2 is also available. The second data you can get is the liver tumor segmentation part 2. So you have to download this also, so which contains the 22 GB of data, so around the 60 GB you will get. So once these two files are downloaded, so just what you have to do is just merge those two folders in one, uh, and make it like, where it is, documents AI, and the here. So just to have two folders like segmentation and volume. In segmentation, you can contain the whole data set here, and the second one is the volume one. Okay. So just to do this part, this is how we can download data set. Then let's move to the coding part. So in the coding section, first we are installing all the dependencies which contains Monai and other NumPy and other things. Okay, then to pre-process sections. In pre-process, again we are just importing some dependencies from the library, and then we are having some functions like create groups, then dicom to nifty, find empty, prepare. So in our case it is not going to be useful, we haven't used this yet, because our data set already pre-processed. Okay, these things are useful when we are having dicom data set and we want to convert to the nifty. So in that case it is useful, and make sure you use this extension correctly. If it is a nifty, then go with NII file, or if it is not Nifty, then something compression is also there at .NII.gz or something like that. Okay, okay. Then okay. Uh, Then in the utility section, we used most of these functions. So we imported libraries. Then this dice metric is a function. So it will predicate and the target the labels like that. So it do that functionality. Then calculate weight. Then train will train our model. So here we have used some device like CUDA core. Then here some main training is happening. Then here the so patient, so this is also function. You can go through this also, like what it is doing and what we can change. Then calculate pixels is one of the function. Okay, think the what kind of errors I got when I used Google Colab for the training. First of all, as you can see, the my thing is my device is not connected. Okay, before that, what you have to do is just go to runtime and then go to change runtime type. Here you can see my hardware accelerator is GPU. By default it is none, so make sure you use GPU because our training needs CUDA. Okay, it needs CUDA core to train, so that's why we will go with GPU and just save it. Then after go here and or the connect to the, or just click on the reconnect. If it is already connected, then it will just refresh this page because my runtime is already set, so that's why. So just so now it is allocating the resources, connecting. So wait for few seconds. Now it will allocate. There are some limitations of Google Colab also, like right now we are on a free version. Okay, so our resources will often disconnect if we want, if we kept it ideal for a long time, let's say 10 minutes or half an hour. If we are not touching our system or this Python are running, then it will just deallocate the resource. So then we have to reconnect. And whenever we are reconnect, we have to do perform the whole step from the beginning. Okay, so just keep this thing in mind, and we are getting only 12 hours time to train our model. Okay, not more than that. Then after again it will reschedule. So if you're having a bigger data and to train, then it is very difficult here. So for that we are having Google Colab Pro also. For that they are charging $10 and much more stable connection and all. Along with we are getting the total training duration of 24 hours. Still it is not recommended for the larger data sets. Okay, here you can see, if you click on here, you can see we got us a RAM, GPU and disk. Okay, so I have created, so this is the thing, and we cannot directly use CUDA. So for that I have created one testing algorithm. So testing some code. Here you can see if we are having this GPU, then it will tell like which kind of GPU we are having. Does this device is there or not, and what is the type of device, so device code. So you will find this same code in so many locations on the in above code or down code. Okay, so by this we are connecting to the device. Then now this is a training part. Okay, here again we are importing Monai, uh, and this is very important. Okay, so in a training part, so this data directory and model directory is very important. So make sure what kind of data directory you are using. So for this, I have used Google Drive. To connect that, just go to that file section. Here you can see this Google Drive logo. Right now it is connected, so that's why it is showing this part. If I want to unmount, I will just click it. So you have to click it here. Then it will ask some login permissions and all, and just connect it to your Google Drive. So here you can go to click on Drive, then My Drive. Here you can see this lever section. I'll just show it here. So this is my Google Drive. So in this I have created one folder lever, and it is having two subfolders. Name is dataset and the results. So in dataset, again we are having four folders. So naming is also very important. So make sure you just have same name. So two folders for the test and two folders for the training. Okay, so in training, just try to have as many data set as you can. So train segmentation, so it's having all the segmentation. So right now I'm having a 20 data sets here, and the train volume is also the same one. So this is a DICOM file by default, and the segmentation is nothing but a label. Okay. So tasting also the same. For the tasting, I'm having the some copy of the data. It's the same one for the volume also. And in the result section, result is having one model folder. Then in model, just now this model will be created here. Okay, so this is our model, AI model, and these functionalities are like for the testing purpose, means how our efficiency, what is the efficiency of our model. So those things will be read from here. Okay, so this is how the data structure will look like. So in this also, like the go to, if we are having like this data set, right? So here I selected data set, so click on these three dots, and here we have the copy path. So just paste it here, that's it. Okay, for the model directory also the same. So model is in the result, and then after model folder is there. So that's why I click on here, then the copy path and paste it here. So this is the data directory. Then after, okay, it's all about the game of means what kind of value we are setting here. So how many channels we are keeping, what's a model epoch and all, and what is a sigmoid, or it's a 1 e raised to minus 5. The same thing, we can change this parameter. Okay, so we have to play with this depend upon the output we want. So right now I have used the 600 epoch. Okay, uh, then once the training is started, so hidden output, as you can see, first it will load the data set, and then after it will start all the epoch and all those things. Okay, so the training will start here. This took around half an hour for me to train the model. Then after the testing starts from here. So here we are, once the model is built, then we will test it, does it is accurate or not. So for that we imported libraries. Then after again here, so in directories and model directories, so we have given data set and the model directories. Then the train loss, train metric, test loss and test metric. So this we have feeded the path. As you can see that our model directory is having already these files, right, after training a model. So we have just given that those name here. Then we have created a graph, means how our training is look like. So as you can see, uh, here there is one problem, like I'm not having enough data sets, so that's why my graph is like this. Okay, but it should be like it should look like this. Wait, what is my current color? Okay, the by default the graph should look like this. Up to some level it should come to this point. So once it reach this point, then we can stop our training. Otherwise our model is going to be like a memorized data. We don't want that. So once we found in this region, then we can stop our training. But because of lack of data set, our model is not accurate at all. So still it needs so many data set to get accurate output. Okay, so this is the thing based on the epoch. Okay. Hmm. Secondly, Hmm. Here we will get, so for the training volumes and the segmentation, then here also just to make sure you are using correct extension, uh, extension. Okay, otherwise you will get error and you are unable to find why you are getting such error, from where it is generating. That's a drawback of Monai. uh, but you can, after some hours, you will just solve it, not an issue. Then this is the code, some code. Then here also the how you are just printing out how your model is going to be look like. So you are just printing this model, means how it is, what is the kernel size and all those things, how many levels it is having. Okay. Then after, here we are just feeding our data set to test. But as you know, like our data set is not, sorry, our model is not accurate. So we didn't got any output. Otherwise, we will get some output here. Okay, that's it in this video. Thank you.